डायमेंशन एनालिसिस हमको क्या बताता है, मैं यहाँ पे लिखा टाइम सेव करने के लिए, मैं ऑलरेडी लिख के रखा हूँ यहाँ पे। तो फर्स्ट ऑफ ऑल डायमेंशन फार्मूला एनालिसिस का डेफिनेशन क्या है यहाँ पे, सी हियर. First of all, you see definition. What definition tells us? Okay, I'll read it and you can take these notes as a, and you can take it's a screenshot also. Okay, see, I'm reading here. The dimension of physical quantity as the powers to which the fundamental units of mass, length, time, okay, have to be raised to represent a derived units of the quantity. So it means what? The whenever we are writing the derived quantity, derived physical quantity, so okay, whenever we analyze its equation according to the fundamental quantity, so that whatever quantities are present in that equation, we should write in terms of the dimension form, that is in square bracket, and each fundamental quantity should write in a dimension bracket, okay, in dimension form. Okay, so now see here. So the dimension formula, what gives information to us? Okay, so first point, the dimension formula of a physical quantity is an expression which tells us, what tells us, see here, the fundamental units on which the quantity depends. It means what? Whenever we are writing a derived quantity equation form, so that by looking that equation, we can say that the derived quantity depends on the some fundamental quantities. Okay, fundamental quantities, and power indicating what? That fundamental quantity, those many times it is representing, those many times it is representing there. Okay, and it tells us the nature of the dependence also. Nature also. Nature means what? How it is depending. Okay, it is directly or inversely. We can we can clearly understand by looking that derived quantity equation. So an example is here. One example, velocity or speed equation is there. Velocity speed equation is what? Distance by time or displacement by time. Distance by time or displacement by time. It means what? Their mass is not there. Mass is not playing any role in that equation, derived quantity. Okay, velocity equal to, you know that equation is what? Velocity equal to displacement by time. Displacement by time. So it means what? Here mass is not playing any role. So then also we have to write in terms of the mass also with power 0. Absent means what? It is with power 0. We should write in that dimension form. So now you see the dimension formula, dimension form of the velocity is equal to what? In bracket, in square bracket, opening, okay, opening square bracket, m to the power 0. It means what? Mass is not there. Mass is not there, it tells us. So then length L to the power 1. L to the power 1 means what? Here length present there 1 times. Length present in 1 times in numerator. Plus means what? In numerator. And t to the power minus 1 means what? It is also representing 1 times. Okay, it is exist there in that for derived quantity 1 times, but in denominator. Minus means what? It denominator, inversely proportional. Inversely proportional. Okay, so this is the clear concept of dimension analysis, why we should read this one to understand the derived quantity. Okay, and to write in, so we are, by learning this dimension form, we can able to write something like a unit, and whatever, we can check that equation is correct or not. Okay, and we can convert one form to other form in system of units. So there are 4 units are there: CJ system, FPS system, and MK system. Okay, MK system extended form is the SS system. Okay, so in that one we can convert one form to other form, because whenever we are solving the numericals, all data should be in the same system of units. Okay, same system of units. If the datas are in different system of units, if you take as it is in the new solution, you are getting wrong answer. Okay, that's why this concept is very important. Okay, In dimensions there are four types are there. Here space is not there. I'm here discussing two, and afterwards we will discuss two more. Okay, so there are four types of the dimensions are there. First type of dimensions are dimensional constants. Dimensional constants means what? Their values are constant. Their values are accepted as a constant, universally constant. Okay, or on Earth in some particular space it is constant. We are taking it as okay. So example you take here. I am showing. The definition is states that these are the quantities whose values are constant and they shows dimensions. Their values are constant, but they show dimensions. They show dimensions. Okay. Generally, many constants are there. They are dimensionless constant, but here these quantities are showing constants. So even though they are constant terms, वो कांस्टेंट है तो भी उनका डायमेंशन हमको मिलता है यहाँ पे. ठीक है, तो यहाँ पे एग्जांपल मैं लिखता हूँ. यहाँ पे थोड़े एग्जांपल, बहुत सारे एग्जांपल है, मैं दो एग्जांपल में यहाँ पे लिखा मैंने. तो फर्स्ट एग्जांपल क्या है? वेलोसिटी ऑफ द लाइट. तो हमको पता है, वी नो दैट वेलोसिटी ऑफ लाइट इज अ कांस्टेंट इन वैक्यूम और इन एयर. ओके, दैट कांस्टेंट वैल्यू वी आर टेकिंग approximately 3 into 10 to the power 8 meter per second. 8 meter per second. Okay, 8 meter per second it is. Okay, the meter per second, this is the dimension. These two are the dimensions. So if you write this velocity of light in terms of the dimension form, so in bracket you write here square bracket c is equal to, here mass is not there, mass you write power 0, m to the power 0, and length is there, meter is there. It means what? Here once it is there you write it, and per means denominator, once it is there you write power 1, t to the power 1. Okay, so even though c is a constant, we are taking as a constant value, but it is having dimension. Second, one more example I am taking here. So here universal gravitational constant, we know that in gravitation chapter we have learnt already. Okay, we will learn later on, not learnt, we will learn later on. Okay, so here gravity, Newton's law of gravitation formula is what? F equal to capital G m1 m2 divided by r square. So here G is the universal gravitational constant, and F is a force, m is the mass of the one body, m2 is the mass of the other body, and r square is, r is nothing but what? Distance between them, center, distance between the center of the two bodies. Okay, so here formula is this one. So from this formula we can write in terms that G equal to that formula like this. Okay, capital G equal to force r square divided by m1 m2. Okay, force dimension formula, we know that force unit is what? Newton, and it's a meter square, and this is below it is there square, 2 times it is there kg per kg square. So if you write that dimension formula for G, it will give like this. Okay, we can write. So if they ask you to write analyze it in dimension formula, means in detail we can learn, but I wrote here directly. मैं यहाँ पे डायरेक्टली यहाँ पे लिखा मैंने. ओके, मैंने यहाँ पे डायरेक्टली लिखा मैंने, आप भी मैं समझाने के लिए, ठीक है, टाइप समझाने के लिए. लेटर ऑन न्यूमेरिकल सॉल्व करते टाइम मैं डिटेल स्टेप वाइज मैं उसको बताऊँ, उसका बताऊँ. आई विल शो यू हाउ टू write this equation. Okay, so next one more type. So this type is what? Dimensional variable. So dimensional variables, it means what? Here values are not constant, their values are changing. We can change them, their values we can change, but they are also showing dimensions. See here, these are the quantities whose values are variable and they show dimensions. So example I wrote here, two example I have taken. So many examples are there in physics, whatever other than constant terms and some trigonometrical terms are there, no, remaining all are dimension formula with variable values. So here area, I take here area writing in dimension form in square bracket A. C is the symbol of the area generally we are taking, and the dimension formula for that is mass is not there. Mass is not the, in previous topic I show you area how to write it. Okay, mass is not there. Okay, write it with power m to the power. Okay, and unit is square, square centimeter, square meter, square kilometer, like that is like that we are writing. Okay, so write L to the power 2, and t is not there. T, time is not playing any role in the measurement of the area. That's why you write t to the power 0. So this is the dimension formula. But here length changes, area changes. This is not the constant, it is a variable. Okay, next one more is here velocity. Velocity. Okay, velocity is also, it is also derived quantity. This is also derived quantity. And velocity is what we know, that distance, displacement by time. Speed is distance by time. Okay, so distance means what, length is there, and by time means what, denominator time is there. Once it is there, mass not there. So that's why we should write dimension formula for velocity or speed equal to like this: m to the power 0, t to the power 1, and L to the power 1 and t to the power minus 1. So this is a this is a type of the variable values, but they are showing, they are possessing dimension. Okay, so next two more are there, we will discuss. I'll write here.